say in the calendar, you're a bum if you're sitting at home eating bonbons and not in class today, and you don't look at those first 3 videos. I'm not going to go through watching those 3 videos again from somebody different. Very good videos on describing what a radian measure is. Let's move Mr. Samuels over here. So here we go. We're going to do what we did in that first video. I'm going to use highlighters. So somebody pick a number between 1 and 10. Hurry up. 7. That's what I heard. So this is 7 inches. Fine. Then when I cut this to be 7 inches, like this arc length is about 7 inches. Then when I complete this radius here, then we'll draw these radii. And of course, that's 7 inches. I don't have to write 7 inches all the way around for each radius. All the radii in one one circle are equal. Then this is what 1 radian is by definition. And I should write the whole thing because some people might think radius instead of radian. That is just what a degree. And if you didn't watch the 3 videos and you're sitting at home, okay, just can't stand it. I'm done. I'm done with the people that are absent and think they have to do nothing. Just drives me nuts. Nuts, crazy. I'm going nuts. These students that cannot function. I'll put 1 rad in there, but if I stop there, 1 radian plus 1 radian is 2 radians. So that terminal side there is represented as 2 radians. Using different colors like the second person in the videos. And then I should put this, another 7 inches, because someone decided to say 7 inches. As discussed when the 3 videos were going in class with people in here, it wouldn't matter if this was 75 miles. Then each one of these would be 75, 75, and 75, and you would still land right about there after 3 cuts of the radius here. All right, and then this would still be 3 radians. 1 more rad. 1 plus 1 plus 1 is 3. All right, and then I guess I'll go this really dark color here. That's approximately about there. That's another 7 inches. I didn't tell you about my wife. She's actually physically having the students with pipe cleaners, which we know what those are. They're bendy little things, making these constructions. And I guess I'll go back to yellow. About 5 radians hits about here. And then they get to see through using those pipe cleaners, cutting them equally, that they do land in this position. And she did bring different size circles for the groups to compare what happened. So if you could just kind of visualize that, I guess that's worth something. This goes a little bit faster. All right. Very creative, though, as far as attacking that this way. And then you really, keep coming. You want to get in the video? Okay, yeah, that you could probably sue me then. All right, give me that sheet, and then, yeah, there you go. Let me check that calculator if you've got any illegal materials on there. Program. This is class fun. Yeah. Oh, let's put your calculator degrees. Just trying to help you. All right, there you go. All right, and then you found out that a radian, let's put this down here so it doesn't, a radian measure of an angle does come from arc length. That's why this is working. Arc length. Did I spell that right? TH? Did I forget the T? Divided by radius. Someone devised this. And I'll tell you right now, radians, this is why this chapter is cut in 2 parts. One is what we're starting with, which is coordinate plane trigonometry. You'll see how that happens. But then the other part is other radian applications. So when you get your angles in radians, you can actually apply it to engineering better. Not that we're going to be engineers, but we are going to do engineering problems. Just real basic ones, because of the idea of what a radian is and how it's derived. But anyway, remember what I told you about circumference? A full circle's arc length is 2 pi r. And when I put that in, that was the last guy. That's why I actually physically looked at that. I looked at the first 2 videos and I said, you know what, though? They didn't really clarify why is 1 revolution 2 pi radians. That's why I got the last guy. All right, and then that is a full rotation. And then that really allows you to do comparisons between angles in degrees and radians, right? And do conversions. So that's what all this means. That's why that blue arc here at the end, this angle measure from here to here is called 6 radians. I don't think I gave it justice. It should be a little bit closer to a full rotation, but it's good enough. All right. All right. So remember what the formula of a circumference of a circle is, and I did and have done what that guy does, but I like his explanation and his graphics. So I've done this with the students before. This is why a full rotation is 2 pi radians. It's related to the circumference formula. So 2 pi radians, that's officially, if you've not written it, is 360 degrees. Full rotation. That's their equivalency. If you divide by 2, then a half rotation is pi radians, which equals 180 degrees. Grant, you're on the video. Nice. Grant was the first one to grab his calculator to find out why is 1 radian, according to one of those videos, 57.29 degrees. This is why. So it was a little out of order. That's why when I showed that, I went, wait, they'll prove that here in a minute. And really what happens is all you did was divide both sides by pi and left the word radian there. 1 radian equals 180 divided by pi. Or do the opposite. Divide by 180 and keep 1 on that right side. So then pi over 180 equals 1 degree. So that leads to these conversions that you really need to write down. But then here's the problem as you're writing this down. We got coin flippers in here. When we got 2 different things for a question, some people just flip a coin and pick one. And then you're right what percent of the time? 3, 2, 1, go. 50. Which is the minimum grade you can get in Lockport if you actually show up and actually write on a test. But anyway, right? Is that right, Grant? Yeah, he knows. Not that you've done that, right?
I have.
Oh, you did? Oh, in the first semester? I'm sorry.
Yeah.
But we're different now, right, Grant?
Yeah.
Good. Grant's getting a lot of video time right here. All right, anyway, so you know what's cool about this? I'm going to teach maybe 6 more years. I'm going to keep this video. And then when I play this, because I'm lazy and I just replay videos, Grant's going to come back in 6 years.
Yeah.
Legendary. Dimensional analysis. Here's my first student of the day. Okay, enter. Oh, it was student number 1. All right, so here we go. We're going to do some dimensional analysis. So, okay, I guess I'll say the names. Vanessa, are you ready? Oh, that sounded confident. 7 feet over 1 second. This always has made me sad, students that make a big deal out of dimensional analysis. And the reason I'm going over this is actually this is 100% going to apply in this chapter. When we get into the non-trigonometry part of radians, the engineering, there's going to be a ton of dimensional analysis anyway. So you need to know how to write the fractions down. So Vanessa, first of all, how many seconds are there in a minute? 60. So we are going to multiply this by a fraction. What goes on top? 1 minute or 60 seconds? 60 seconds. Why? Tell me, what has to cancel? The seconds. And this is all dimensional analysis is, and I don't understand why students think this is hard or are unable to do this. I don't know, again, if it's that fraction brain block, because really it is dealing with fractions. I don't know what it is, but keep going, Vanessa. How many minutes are there in an hour? So then where does the minutes go, top or bottom? Top again, because minutes have to cancel. I don't understand how this could be an issue. It is actually the most simplistic concept if you understand fractions at all and how things cancel. And now I have hours on the bottom. And then I am going to expect you to know this, and you will have to know this later in this chapter. Vanessa, I'm going to put you on the spot. Do you know how many feet are in a mile? Putting you on the spot here, and you'll probably be like 50-50. Half the class knows, half the class doesn't. Oh, okay, so 5,000. Do you remember now? No? You're going to have this memorized. Go ahead. All right, so I put you on the spot there. And I'm going to expect you to know this. You know, I think you should be able to walk out of here and know that, oh, I should have asked you this, Vanessa, but I think you got it down. Where does the feet go, top or bottom? And hopefully you knew the bottom because feet have to cancel. Then when you look at this, what's left over? Miles per hour. Yeah. And then how do you handle this? I'm not telling you how to type this. I did have some, you better watch yourself later though. And actually that's why part of your notes is you type on your calculator, right? And you play along and you know how to type it. But this one's pretty easy. 7 times 60 times 60, press enter, and then it's just divided by 5280. You only have one number on the bottom. What the people screw up is if there's two numbers on the bottom, then you have to hit divided by parenthesis, number times number, and then you have to divide by the whole product. Some people still don't know how to do that as a senior in this school. Okay, now, this is why I went over this. This is why I went over dimensional analysis. A, it's coming up, so we do have to know how to do it. B, you can use dimensional analysis to not flip a coin. So I'm going to pick my next student. Entry. Nice, staying in that row. Guess who? Student number 3, Eldona. Okay, so this is a radian measure, and then no one's been in Math 3 honors, so they don't even know this. But usually with radian measures, they do have a pi in it, but it doesn't always have to be the case. So we're going to pretend we know nothing and put the word radians in front of this. Now, according to dimensional analysis, I want to make this over 1. Just do that. Just do that. And then times Eldona through dimensional analysis, where do for my conversion ratio, where does radians have to be, top or bottom? Because remember what happened up here, the whole canceling thing, right? So I had seconds down here, so seconds had to be up on top of my conversion. I had feet up here, so feet had to be down here on my conversion. So where does radians have to be in order to get rid of radians, top or bottom? Bottom. And that's why this is 180 over pi. Or another thing you're going to find out is, now I'm going to get rid of this fraction. Yes, radians usually have a pi in it. What else will cancel? Eldona, I hope you know your basic fractions. It starts with a P and ends with I. We're running out of time. Pi's will cancel. Okay, and that's going to happen as well. So the word radian cancels. I know they didn't have the word radian. You should kind of insert it in there so that you can cancel the word radian. Radian divided by radian turns into just a unit, of measurement. What unit of measurement's left? Oh, degrees. So this will be degrees now. That is the word degrees, by the way, that symbol. Anyway, through doing this numerous times, I think we end up with, did anyone type this out? Is it 324? Did anyone do it? I just look. None of the seniors actually type on their calculator and help us fella out here. Just sit here awkwardly and just stare at each other. This is like, is it 324? All right, so the ability to type that and get 324 degrees is on you. Okay, so we're done with that. So